Let's say I want an image of a Qutub Minar drawn in the style of a Van Gogh. I will get that, right? And it will exactly in the same theme as a Starry Night that most of us have seen, right? How does that happen is basically so the weights can be defined by humans as well. If I say make it look a more like Van Gogh and or something like the art form of Van Gogh, it will understand the text that is given and based on that it will give out the answer.
Hello and welcome to the Filter Koffee Podcast. We're recording this episode in November 2022, and I think it is safe to say that in the last month or so, most of us have seen or read a news article which has the headline on the lines of, "We asked AI to create ABC, and this is what it came up with." The article, of course, will feature a mind-blowingly creative, futuristic, and an aesthetic image whose source would have been a text that's been fed into the system. My favorite so far has been what a journalist gave as a command, which is, quote, "Teddy bears working on new AI research underwater with 1990s technology," unquote. If you haven't already, please look it up. All this started with a platform called Dall-E. The name, by the way, is a fusion of the name of the famous painter Salvador Dali and my most favorite animation film ever, Wall-E. Dall-E has been made possible by OpenAI, an ambitious not-for-profit research laboratory founded and funded by a team that includes Elon Musk. In this episode, I'm joined by my friend Harsh Songra, who usually is the guy I turn to help me break down tech wonders like this one. I spoke to him about Dall-E GPT-3, which is the underlying technology that makes this work, OpenAI, and what we can expect in the next few years, and much, much more. Harsh returns to the Filter Koffee Podcast after being a part of episode 57, which I think we recorded like a million years back. Back then, we had spoken about his first startup, MyChildApp, which he built when he was not even 25. MyChildApp helps parents identify developmental disorders with their children so that early intervention is possible. Harsh now is the Vice President of Technology at QKey, one of my favorite creator companies. He's also a Forbes 30 under 30. Enjoy this episode where Harsh breaks down for us the technology behind text-to-image using AI. And stay with us as we come right back after this very short commercial break. Welcome to the Filter Koffee Podcast, Harsh. How are you doing? Where are you talking to us from?
I am doing good. I am talking to you from Bhopal. I'm here for my Diwali break. I'm talking about AI on my Diwali break. काफी interesting.
Yeah, Bhopal, AI, Diwali break, they all seem to have like a weird science fiction backdrop to the whole thing, which is in a way good for the conversation.
Yeah.
Before I go anywhere else, welcome back to the Filter Koffee Podcast is what I should have said. After after Ashok, you're the second guest who's making a comeback on the show. So
Yes.
thanks for that. We've been talking about this for a while. And as some of the listeners might know, you're the guy I usually call to understand what technology is coming at us, not what's there today, what's there tomorrow, but what's going to happen day after tomorrow.
Yeah.
You're like my go-to guru for that. And from that perspective, I think all of us have been very, very excited and mildly terrified by what this, or rather, what tools like Dall-E is helping us do today, which is text to image through artificial intelligence, right?
Yeah.
And every day at work, with friends, we're all talking about, okay, what is the possibilities of this? What is the more interesting phrase we can input into the whole thing, so on and so forth. So I thought it'll be interesting to bring you to sort of demystify this for us, which is also why we're calling this episode a latecomer's guide to Dall-E and other things. So, we've spoken, and I know that before we go into how Dall-E works, I probably need to demystify a couple of other things, right?
Yes.
So let's start with OpenAI. Talk to me like I'm a 6-year-old. Help me understand what OpenAI is.
Okay, so a couple of years ago, like Stephen Hawking, Elon Musk, and a bunch of people came together and signed a paper that said that, hey, artificial intelligence after today is going to evolve and evolve and evolve further, and it should not be used to develop weapons of mass destruction. Okay, so that was a paper that a bunch of scientific and technological committees came together and signed as a pledge to the world ki, please don't do something like that. Okay,
So to ensure that AI stays with the good guys.
to ensure that AI is not used to create a weapon of mass destruction.
Okay.
Weapons of mass destruction needs a lot of money to be put beyond it. So just any Tom, Dick, and Harry cannot create it. Only governments can create it, right? So this was just to ensure that governments don't do like a
Hmm.
drone which uses AI to figure out if someone is a terrorist or not. It's
Right.
not a useful thing. But after that, I guess Elon Musk and a bunch of people again came together and they wanted to start a foundation that, that says that if we are the good guys, we should be ahead of each and every bad guy and figure out this technological development before them so that we are ready with the tools to save ourselves and we are ready with the evolution that comes further. So that was the main objective of setting up OpenAI. It is just a AI research foundation
Hmm.
that keeps on building neural networks, transformers, basically ML engines. If people will build privately, they will have too much power. But if you build it openly, you can distribute to the world and make it a level playing field.
Right. I'm going to look at this from the POV of someone who doesn't understand this. But at the
Yeah.
same time, I don't want to go into detail about some of the terms which have now become commonplace, right? But
Yes.
I think neural networks is probably something that people don't really understand fully. And since you mentioned it, do you want to just break down what is a neural network?
Okay, so let's take a step backwards. I don't want to keep it long, but AI is not something that is very new. Okay, AI has been
Right.
very old. People have been building sculptures of humanoids and, back in the Egyptian centuries as well. If we actually want to talk about understanding AI, then it comes from Alan Turing's paper called the Turing test, which was also named the imitation game, which he wrote in 1950. And there he mentioned that when a machine will have an ability to exhibit intelligent behavior equivalent or indistinguishable from that of a human, they will pass a Turing test. After he wrote this paper, everybody started building stuff to pass the Turing test. Government started putting in money and all that. So सबसे पहले I am algorithm, which was basically if I tell you do this, else do Y. Then came something like data science, where algorithms were running, but instead of just getting two or three inputs of data, they were getting multiple inputs of data. And then based on that, they were doing statistical analysis, and then the algorithms were running. Then came something like machine learning, right? Which most of us might be aware about. Machine learning is basically the same thing that data science does, but it can work for 2 to 3 layers, right? Like one input layer, one output layer, one model layer, basically, right? Model layer में decide हो रहा है क्या हो रहा है क्या नहीं हो रहा है, and you give it a set of data. You give it with the data. You also give it a set of weights which was not possible in the past. And then based on the weights, the model will tell you what to do next. Like the output will be dependent on that. But
Right.
see, when I explain you this, you would also realize that, hey, I mean, this is nice, but it can only scale to a limit, right? If you have
Yeah.
to imitate the way a human thinks, you cannot just give it 3 layers of thinking and ask it to think the way a human does, right? So a deep learning network or a neural network or a neural engine is basically layers of technology built on top of each other, working on different models to provide unsupervised learning and unsupervised output which humans want to have. It's as
Right.
simple as that.
I'm going to paraphrase this in my own language. You got to tell
Yes.
me if I got this wrong, right? Like, so
Yes.
I think, the fact that AI works with different data sets is something everybody understands. But what we call as intelligence and
Yes.
why the human brain is so powerful is that it is able to build in real time a lot of relationships between these data sets, right?
Exactly.
And that is what, for example, neurons in our brain are sort of trained to do. So in a
Yes.
way, these algorithms that we refer to as neural networks sort of mimics how the brain works into
Yes.
helping us leverage multiple data sets, understanding relationships, and then remembering it for future decision making, right? Am I
Yes.
sort of close in the ballpark?
Yes, you are close to the ballpark. Basically, we are trying to replicate how our neurons work, which are, by the way, billions of out there,
Correct.
and use the computing power that we currently have to replicate the way a neuron will think about a certain set of problem. It's as simple as
Right.
that.
Okay, cool. So we've touched one part of
Yeah.
the essential ingredient to understanding how platforms like Dall-E work.
Yes.
The other part is much more in the technology ladder, much, much lower, which is alt
Yeah.
text. Right?
Yes.
What is alt text and why do we already know this?
Okay, so all text is simply so you remember that I have told you about unsupervised learning, right?
Yeah.
Now, what's happening is if you want to build an engine that goes around the world and tells the world that hey, I want to build a image that looks like a panda sleeping in a spacesuit, right? You would probably, if you will just search for multiple humans going around and labeling those images, it would be like so very hard. That's why we have something like unsupervised learning, where you have the labels already built in one way or the other, and you use that as a data point for the image. Now, because of the way people use SEO and the internet, alt text is the mechanism that most of the image engines are using to figure out which image suggests what. So if I have an image of panda, I can do two things. I can either ask a human to say कि ये panda hai, like click on it, this is a panda, which has been done in the past. They do use some human label people who label images who are human.
Labelers. Okay.
Yes,
All right.
labelers.
Okay.
And sorry. And apart from that, there are certain alt texts that are already there. So the machine already knows what an image of panda looks like. It just takes the alt text and superimposes it and tries to understand whether this image is the same or not.
Hmm, great. Okay. Now we have AI, machine learning, and then we have things like alt text, which is explained how it works. How is a platform like Dall-E able to bring all of this together and work the way it does? Right, let's go with the same example you said. I love the example of a panda in a spacesuit. Right.
Correct.
Help us understand, a blow by blow account of how this works in the back end.
Sure. So I will take a step back and try to make you understand one thing that I might have missed out in my previous explanation, which is the, like increase in the processing power that we as humans have today as compared to what we had in the past, right?
Right.
What does a computer do? It does a number of calculations per second, and that's called your processing power. It's as simple as right. In the previous years, we used to have transistors on a chipset, and those transistors we had like a Moore's law, which stated that every few years the number of transistors in a particular area in a chipset will double. Right after a point, we hit the boundaries of physics over there. So then we started working on something known as GPUs, right? Graphical processing unit, which can do floating point operations, basically decimal operations as compared to integer based operations, right?
Right.
And then because of that, we were able to evolve to a much more bigger use case of artificial intelligence than we can do right now, because multiple calculations can happen right now simultaneously as compared to just one. What Dall-E is doing is multiple calculations of figuring out, how I can generate a realistic image based on the natural language prompt that I'm given. It's as simple as that. It will go around. It has been trained on a set of concepts, attributes, and styles of various artists, various, like objects, where various filters, And then based on that training model, it tries to, like match it with the natural language prompt that is given to us and show us a result that we can see.
Okay, now I'm going to ask you a question that's part technical, part philosophical, and I
Yeah.
need to go into flashback mode for this. See, when I was
Yeah.
in college, briefly, I was very proud of being an atheist. It was very brief because I
Mm.
realized that atheism is as much of a conformist as someone who says there is a God. Right. So ever since then, I've become more agnostic in my search. But at that point in time, for me to prove that religion is a
Mm.
scam, I had this theory. I call this the pink elephant theory.
Yeah.
Okay. So the theory goes something like this, right? I'll ask someone to imagine a pink elephant. And
Mm.
the person will say that, of course, I can imagine a pink elephant. Then I'll tell them that what you're probably imagining is pink on an elephant because
Yeah.
you've seen that before. You
Yeah.
could have seen that before. You've seen
Yeah.
paint on an elephant for sure. But you've not seen a pink elephant. You've not seen an elephant that was born pink.
Yeah.
Right? So because of this, you're not able to visualize something you've not seen before. Right?
Yes.
And my whole point was that everything you know about God is something that you have read, or rather, everything you know about God prescribed by a religion is something
Yeah.
you read in a holy book.
Yeah.
Right? So it is, in that sense, something that is based on stories.
Yeah.
Right. And hence, tomorrow, if the real God comes in and says, hey, dude, chances are that only one or at best two of these stories will be correct.
Yeah.
Right. So the other story will not be right because
Yeah.
it's not. The stories are not the same. And of course, all of this is fairly juvenile now that I think about it. But at that time, it held a lot of water from a rationality perspective, right? So my whole
Yeah.
point was that, listen, the chances of your God being actual God is less than or equal to 20% or so,
Yeah.
sometimes even 10% or so. And if you won't put 100 rupees of investment in it, why are you putting your life as an investment in the search of that God, right?
Yeah.
Sorry, long-winded question, long-winded background to a very short question, right? We spoke about neural networks and all text and all of this. Right?
Yeah, but now you can create an image of a pink elephant definitely from Dall-E.
Exactly my point, right? Now that you can actually create it, but how does Dall-E differentiate this from pink on an elephant? Right, like either with your panda spacesuit example or with the pink elephant example. Can you help us understand this better?
Okay, sure. So it uses a process called diffusion for the same thing, right? Now, what researchers at OpenAI and generally with these, transformation models or basically diffusion models, these people do is they train a lot of, as we talked about, images on a relationship that they have with the text, right? And what based on that text they get the concepts and attributes and style. Now what happens in the process of diffusion is it starts with a pattern of random dots. Think about an image filled with noise, right? It will be just gray and RGB dots on the image, and then it will gradually alter towards an image which basically is the same as the natural language prompt. The aspects are equal to the prompt that is given to it, right? So there are two things that is happening over here. One, there's a language engine that is processing and understanding what the human is trying to say. Okay. So what it is doing over here, which OpenAI already did with something known as GPT-3, we can talk about it later on, but basically what it does it understands text. It's as simple as that, right? So one, there's a language in the engine processing and understanding the text. Okay. Then there's a diffusion process happening, which is trying to figure out what are the attributes that are given in the text and then matching the attributes of a particular noised image which with those text and then denoising it to a particular place where all the attributes match to the prompt that was given. Like, if I have to explain at a very high level, it is still very complicated, but this is the entire way in which the process is happening. And like the funny part with Dali is, you expect to just go to one level, right? But this is something that can add shadows. This is something that can add images. You can literally say that, hey, make the image look a bit like vintagey, and it will create a filter that will not be just like a random Instagram filter. It will actually look vintagey in shadows, reflections, textures, and everything.
Yeah, the image that comes to my mind as you talk about it is there was a fantastic Wall Street Journal article on the subject,
Yeah.
and one of the things that the journalist had asked Dall-E is give me an image of colleagues, struggling with paper stuck in a printer, but make it a medieval painting sort of a tone.
Yes.
Right,
Yes.
like so there's a printer in medieval sort of like
Yes.
Roman times, and people are struggling with the paper side, right? So what I'm trying to understand is, you use the word natural language processing, right? One of the
Correct.
and natural language processing, for those of us who are in the business of marketing, is not necessarily new. So the way it works is that we've seen this in what we refer to as social listening tools, right? And natural language processing is almost like Boolean algebra, but using
Correct.
the words that you use, right?
Correct.
Let's say if I'm adding, three or four terms, right, to the text I'm inputting to Dall-E, right? So
Correct.
let's say, medieval, printer, paper stock, etc. How does Dall-E give weightage to different things? Because I'm not qualifying that, right? Should it be more medieval?
Exactly.
Is diffusion the process that defines it, or
Yeah.
how does that work?
Okay, so in Dali, you can actually give it any kind of text and it will generate an image either exactly the way you want or in the style that you want. What I mean by that is, let's say I want an image of a Qutub Minar drawn in the style of a Van Gogh.
Hmm.
I will get that, right? And it will exactly in the same theme as a Starry Night that most of us have seen, right?
Yeah,
How does that happen is basically so the weights can be defined by humans as well. If I say make it look a more like Van Gogh and or something
sure.
like the art form of Van Gogh, it will understand the text that is given, and based on that, it will give a the answer, right? But what's usually happening is it again goes back to the training. Based
Hmm.
on the training, it has understood what are the attributes an image is having, what are the styles an image is having, and what are the concepts an image is having. It has divided those attributes, styles, and concepts in a bunch of zeros and ones. And it knows how to mix and match those zeros and ones when someone is asking, hey, give me a picture of a Qutub Minar that is drawn by a Van Gogh. It's as simple as that. Like basically it knows like our brain. If I have to imagine a pink elephant, I know how a pink color flamingo probably looks. I
Hmm.
know how a elephant looks, and I know what a diffuse model of a flamingo and an elephant would look like.
Okay, cool. So just moving slightly away from this, in the middle of explaining this, especially when you're talking about natural language processing, you were talking about GPT-3, right? Tell us what is GPT-3 and why is it important?
Okay, so GPT stand for General Pre-trained transformation, whatever. It's a transformer engine which basically knows what kind of text to give as an output based on the inputs it is given as a prompt. I'm oversimplifying it, it's fine, it's very complicated, but basically if you'll ask it to write a marketing copy for ABC based on your model, right? Let's
Hmm.
say if you will ask it to write a marketing copy for a Facebook ad that says IVM Podcast, it will write a marketing copy for a Facebook ad that says IVM Podcast. It might not be as great as an A plus writer, but it will definitely write something to a level of B minus.
Right. So what you're saying is that moderate copywriters should definitely be worried about the job.
I'm not
You
saying
can
that.
completely ignore that point. Please go on. Yeah.
I'm ignoring. Okay, see, the point is what's happening over here is it has understood how humans talk and converse and what we write and the various forms of writing that we have, right? So there has been a story about a kid who used a GPT-3 language model to write his school essays, and did not spend time in writing those essays, and he got a B plus, which is a fair score, right? For an essay,
He
that's
got a B
super
plus
score.
after the teacher knew about it or before the teacher knew about it?
Before the teacher knew
Oh,
about it.
wow. Okay.
Yes. So, I mean, the use cases are endless. I feel that. But so, yeah, like there has been a lot of these stories coming out, and there has been a lot of tools also coming out that uses language prompts to give out text-based outputs. All of them are based on GPT-3 nowadays. So it's just a normal engine where you give a text and it will give you a output based on the kind of text that you are asking.
Right. The relevance of GPT-3 to a Dall-E is that, is it fair to say that GPT-3 helps platform like Dall-E sort of understand what is being written, helps with the natural language processing piece?
Correct. It does a couple of things with GPT-3 which other language models cannot do, right? It basically one tries to figure out, concepts that the text is trying to talk about. If I'm trying to talk about a panda sleeping, what does a panda sleeping actually mean? Right? Right.
Right.
Like if I say that a panda sleeping while snoring, right? That's a different concept altogether, right? So it understands the concepts really well. Then it divides the attributes, right? So attributes are like the colors I will give, or the skies I will give, or whatever. And then the styles maybe like styles are like attributes, right? Like maybe like how I want the image to be placed. Like, do I want a full HD image, or do I want a Facebook thumbnail, or something like that, right? And
Right.
all of that needs to be understood from a text processor or a language processor. It cannot be just understood by computers, but all because all a computer will understand is 0 and 1. So how to interpret those text forms into a 0 and 1 is what GPT-3 is doing.
Right. As you talk about GPT-3, right, I think one of the things that comes to my mind is, and I don't know how old this is, I want to say it is 2016 or so. There was an attempt made by a bunch of filmmakers to let AI actually write the script of a film, right? And they decided that it's going to be sci-fi film. So what the AI engine was fed was a bunch of scripts, from Star Trek to Star Wars to multiple other things, right? And the AI engine came up with a script which it titled as Sunspring. Okay. It's a fairly interesting, intriguing, also mildly hilarious film which stars Thomas Middleditch. And it's one of those films where you know that there is an element here that you've seen somewhere in a sci-fi film. But what was interesting is that overall the film didn't make sense. Okay.
Yeah.
The film didn't make sense from a reality lens. They still went ahead and actually filmed it, the way they would film a sci-fi film with sets and great production value and music and all of that, right? And you can just Google Sunspring and watch this on YouTube. That Sunspring. But the thing is that it didn't make sense, right? So to me, there was a bit of a reality check, and that this is at a movie level, which didn't work. Right. If I look at what's happening with Dall-E now, there is like I said, if you go to that example of a panda in a spacesuit, it really looks like a panda in a spacesuit, right? So somewhere I feel like there is a reality check. When I say reality check, I mean in terms of that, can this image look as real as possible? Can it look as real life as possible, right? What is helping us cross that barrier?
So, couple of things, right? One is, of course, the processing power that is improving every single year, right? So, it's not just the gigahertz of processing that is improving, which is, of course, with the central processing units, but also the GPU power, which is the graphical processing unit that is improving right now. It is also the kind of models that on which like the training is done. If you have written a shitty model and if you have given him it a bunch of amazing things, the output will be still shitty, right? What I mean by that is the output is still defined by human beings. Have to fine tune your model in a certain way that it gives you amazing out. If you're not able to fine tune it in that manner, then it would not give you the output that you require. So, for example, let's say you're using a hypothetical scenario, something like a GPT-3 to write a movie script, right? you will still need to train the model in the way you need the output to be. If you're not training your own GPT-3 model in that particular output based scenario, and you're just saying, ki, hey, I will just use whatever they've created, it will never be as good as what it could be if the model is trained properly.
So what you're saying is that, before a product like Dall-E
Yeah.
comes to the market,
Yes.
it is actually trained manually
Yes.
to make sure these rough edges don't exist.
Correct. And it requires a lot of, fine tuning. The fine tuning phase itself may take multiple months, maybe years, just to make sure that people get the right output. And that's what Dall-E is doing, right? Like they would have tested. I think the first image that Dall-E generated was what, like 2 pixels?
Okay.
And right now it can generate like a full HD image. So imagine the kind of fine tuning that will be required to go from 2 pixels to 500, like a full HD image, which is like 1080 pixels, a big jump.
Right. The thing that also comes to my mind is the more you look at the power of this, from 2016 to 2022, things have like you said, of course, with a lot of training of the models, but we are
Yeah.
able to bring out outputs which are much more real life like, right?
Correct.
So to me, Dall-E certainly looks like something. When I say Dall-E, I mean technologies like Dall-E.
Yeah.
Certainly looks like something that will probably look even better in, let's say, a 3-4 year horizon. Right. If you were to ask me, where do I see this going? I'd probably say in about 4 to 5 years from now, we'll be able to either through voice or through text-based instructions create an augmented reality, not even an augmented reality, even a virtual reality for us in which we can actually
Yeah.
live exactly the way we want. Right? Like,
Yeah.
can I be in a beach where there are giant dinosaurs serving me vodka martini? Right? Could be a reality I can experience, right?
Yeah.
At least in a certain dimensions. Do you agree? And what do you think would be the things we can see in a 3-4 year horizon?
I guess one of the things that we humans fail to like appreciate and understand properly is we overestimate we overestimate what technology can do in a short term, and we underestimate what technical technology can do in a long term, right? What I mean by that is, so the previous example that I gave about Turing test, right? In 1980s, a bunch of professors and everyone was saying like, in the next 6-7 years now, we will be able to make a machine that will pass the Turing test. By the way, we still don't have a machine that passes the Turing test, right? But the goal and the evolution to reach there has made us push the boundaries and made sure that tools like Dall-E and everything exist. Uh, think about it this way, right? When AI was actually evolving in the early days, uh, it was doing a lot of left brain tasks. Like it was beating Gary Kasparov in 1990s. Like there was
Yeah,
a
yeah.
computer, I guess, called DeepMind,
Deep
Deep
Blue,
Blue or
IBM
something.
Deep Blue.
Deep Blue, IBM Deep Blue that was beating Gary Kasparov. Then it went to beating the Jeopardy champion IBM Watson, and then it went to beating the AlphaGo champion. Right, all of them were left brain tasks. Most people did not care about it. But what it allowed us is to build we always say that if a human has critical abilities, he will be able to figure out how to build his right brain abilities as well, right? In the same way, what it allowed us to do is it allowed us to have a compounding effect and build on the right brain task, which was creativity, which was generating images. You can now generate videos out of just a text prompt, by the way. So those tools are coming out there. I guess the next 4-5 years are still years of fine tuning. Uh, I think Dall-E 3 is very far away. Dall-E 2.1 is close by, right? And what we will see in the next 4-5 years is an evolved version of the tools that we already have. And these AI enabled tools or these AI enabled ecosystems will act like a superpower for everyone who is, like building for example, coders who can just use something like a GitHub Copilot to help them code in a better way, right? Or copywriters who can use Jasper AI or Copy.ai to write better prompts so that they are spending their time and thinking more and less in executing, right? Or a video maker who, instead of figuring out what kind of LUT is required, for figuring out what kind of fine tuning is required, just writes a text and the video is edited based on the textual prompts. So I guess the next 5 to 6 years are years of fine tuning, not years of larger evolution. Because the larger evolution will come, but that will only happen after the fine tuning reaches to a place where we can move on to the next step.
Right. Yeah. A related question is that Dall-E doesn't seem like something that is meant for people to have just fun with what it is.
Yeah.
I think its implications lie elsewhere. Talk to us a little bit about what else has been happening since this came about, and this particular track, right, which is text
Yeah.
to images. So what is the potential it can unlock?
So there have been multiple models of diffusion that came out after Dall-E came in. So Dall-E is a closed source model, basically like OpenAI only has a code base. But there are other models like stable diffusion, which is made by a company of called Stability.ai, which basically is the same kind of model like Dall-E, but anyone can download the open source code base, train it on their own, train it and fine tune it based on their own liking, and then get the same results like Dall-E does. Mid Journey is also like a Discord bot, which exactly does the same thing. And all of them are amazing in their own way. See, none of them will give out the same images as a result because, like all of them are trained off different data. But yeah, like now people are like pushing a bit more a step forward. So I'm moving a step forward. What I mean by that is now Facebook created a tool that can help you generate a video, right, out of a text prompt. There's a amazing tool that is in beta right called runaway.ml that is literally like an Adobe Premiere suite. Sorry, Adobe Premiere, but instead of like a timeline where you manage everything, it's just like text and results, right?
Right.
You write that, hey, I want to remove an object remove the lamp from my video. It will automatically remove the lamp from the video, right? You will write a text like like make it look like it's nighttime, and it will make it look like it's nighttime. And interestingly, in their demo video, they had something that shocked me, which is it was like cover the human in a green screen. Sorry, wrap the human in a green screen and change the background to black and white. And it did that, right?
Wow.
It was just a text working with a tool, right? Sorry, text from working with a tool. There was no human intervention, like I'm selecting the human being and everything. None of that happened, right? So these are what I call fine tuning of the previous technology that is out there. What's happening more right now is, so you might have heard these Apple talking about, hey, we have a neural engine in our chip, or hey, we have like or Google saying that we have a GPU in the new Tensor G2 chip. And what these are doing is increasing the amount of calculations that you know computers in our hand can have. That's point number one. But point number two is when they say they have a neural engine inside a chip, It means there is a separate section inside the chip which will just process for the neural engine, just process for machine learning, right?
Right.
This used to not happen before. Before it was just like a CPU and a GPU. They will do multiple other things and they will process the machine learning system. But now we have the power to build chips that will just you do AI, ML, and deep learning stuff. Because of which the fine tuning is getting much more faster.
Beautiful. Harsh, I promised both of us that we'll keep this unlike other episodes of the show to about 45 minutes, so that people
Yes.
get a quick perspective of what this is about. Before we go, one last question is, we usually, as end the episode with what our guests are watching, reading, or listening. But in this case, if someone needs to understand this a little better from an application perspective, not a practitioner's perspective, but from an application perspective, what are some of the books, podcast episodes, videos you would suggest?
I guess Lex Friedman does some amazing podcasts around. So Lex Friedman is like a computer scientist. He is like the second most popular podcaster after Joe Rogan now, and he has done some amazing episodes around deep learning, machine learning, and how these models are working. I would suggest if you just want to understand, the potential of what is being built, go ahead and sign up, right? Sign up to something known as Jasper.ai, Runaway.ml. Dall-E has a playground, right? And use it to understand the potential. I guess it's very powerful to it will help you be less scared of what is being built and more in awe of what it could be.
So if
You
I
know,
sign up for this, what will happen?
it will just take you to a page where you can, give a textual prompt and get the results that you
So you
want
can start
for
using
free.
it, is what you mean, right?
You can start using it,
Right,
right?
right.
And in just look at these. So they are just read the about a section of these websites. I guess that will help you understand it a bit more than some YouTubers and podcasters who probably will overcomplicate it. I hope
Right.
we did not, but yeah, that's mostly happening right now.
This is very kind of you, man. And any other links, books that you enjoyed?
Yeah, so I liked. So there's a podcast by Shan VP and one more of his colleague that's called My First Million. And they actually have an episode called Nine AI Ideas Which Will Make Profit or something
This
like
is
that.
Sam Parr and Shanpuri.
Shanpuri, correct.
Yeah, yeah.
And 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 that episode actually takes you to what AI is doing right now and what AI could do. So if you really want to understand it in a better way, watch that episode on YouTube because they actually share their screen and show you what different sets of AI can actually do.
Awesome, great. Harsh, thank you so much for your time. Thanks for doing this from Bhopal on your Diwali break. And as
Yes.
always, you open our eyes to multiple possibilities. Thanks
Yes.
so much, and have a good Deepavali.
Yes. Thank you. Thanks.
If you like this podcast, don't forget to check out other interesting podcasts on the IVM network. You can listen to us on the IVM Podcast app or ivmpodcasts.com. You can also follow us on our social media. We are at IVM Podcasts on Twitter and Instagram. And if you want to reach out to me, I am _Karthik. That's Karthik with an H on Twitter. And Filter_Koffee, that's coffee with a K, on Instagram.